Hello chemistry fans, and welcome your faces back to chemistry problem solving session for Chemistry 1032 here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'll also be your guide through this problem today. So without any further ado, let's jump right in. Problem 4, Chapter 10. In the following acid-base reaction, identify the acid, base, conjugate acid, and conjugate base for the following. Okay, we've already talked about what conjugate acids and bases are. If you haven't seen those videos, please just go back and find them here on YouTube or wherever we post these and figure out what these definitions mean. But today we're just going to try to identify one and the other. It's pretty simple stuff, I think. And I hope that you do too. If not, I hope after this video you find this to be extremely easy. All right. So we have to find the acid, the base, the conjugate acid, and the conjugate base. Now remember, they come in pairs. So if you find the acid, the conjugate base should follow right along. If you find the base, the conjugate acid should follow right along. So let's look at this question carefully. We have HBr plus water to give us H3O plus hydronium plus bromide. Now let's play follow the atom. Let's follow the bromide. So over here, the bromine, or the bromide, has a hydrogen attached to it. So there's a hydrogen and a bromine together. So let's follow the bromide to the other side of the arrow. The Br has no hydrogen. Let's see that again. Over here, the HBr, there's a hydrogen attached to the bromine. Over here, the bromine doesn't have any hydrogen. So between here and here, the bromine or the Br has lost a proton. So between here and here, the bromine or the Br has lost a hydrogen or a proton. Proton donor. An acid is a proton donor. So the acid in this equation must have been HBr. Must have been. Because between here and here, the Br lost the acid or the proton. Between here and here, the bromine lost a proton. So it must have been a proton donor. So we can draw, if you want, like that. This became that. Somewhere between here and here, this molecule lost a proton. So this is a proton donor. Now the conjugate base is paired up with the acid. So this must be the conjugate base. The conjugate base, remember, is the base that forms after the acid donates the proton. Br minus is our conjugate base. Okay? So our acid was HBr, our conjugate base was Br minus. Now, let's find the base. Well, follow the atom again. Oxygen, oxygen. So from here to here. Here the oxygen has 2 hydrogens. Here the oxygen has 3 hydrogens. From 2 to 3. So from here to here, it gained a proton. It received a proton. 2 hydrogens on the oxygen here, 3 hydrogens on the oxygen there. Between here and here, it has gained or received a proton. That makes this a base. And it's paired up with H3O plus. So now H3O plus must be the conjugate acid. Now, a conjugate acid, remember, is the acid that forms after the base receives a proton. So the base receives the proton between here and here, and this is the resulting molecule. This is defined as a conjugate acid. Okay? Now I hope that this was kind of okay or clear. If not, try watching the video again, maybe that'll help. Or raise your hand, go find a tutor, grab them by the arm, be nice to them, and ask them to help you with this problem. It's a very simple problem once you get the hang of it, but you do have to get the hang of it first. And if you'd rather, come on by and see me during office hours, or your professor for that matter. We're more than happy and more than willing to help you solve these problems. Don't let yourself sit back on this. It's a common chemistry question on exams, and it's very helpful to you in other classes to understand things in biology and medicine and nursing. Okay? All right, guys. With that, I'd like to wish you good luck and good chemistry.